question number 6, 3 particles A, B and C. So side by side, let's make the diagram. A, B and C. So let's take these as 3 particles of masses 5 kg, 1 and 2 kg. So this is your 5 kg mass, 1 kg and 2 kg, and these are particles A, B and C. They lie at rest in that order on a straight horizontal line. So let's suppose this is your whole horizontal line. Now what happens next? They are on horizontal track XYZ, and this XYZ represents these points. Like particle A is on X point, B on Y and C on Z, and they are at rest initially. Particle A is projected towards B with a speed of 6 meters per second. So initially this is 6 meters per second, and at the same instant C is projected towards B, so in this direction with V meter per second. Okay, and in the subsequent motion A collides and coalesces with B to form a particle D. So that means this is before collision scenario, and now we have to make what is after collision scenario. So let's copy this and rearrange it in some way. So A and B coalesce. So what will happen? This this ball is going to be now here. Okay, let's keep that written. The masses 5 kg and 1 kg. Now this becomes a particle D, because now they coalesce and they become one. So particle D then collides and coalesces with C to form a particle E. Okay, now this moves towards C, which is already moving towards Y. Now it is not at Y, obviously it's moving, so it's going to be somewhere in between. Okay, so it must be somewhere here. So this is your first collision. Your last collision would be like, somehow it looks like this. Now they will be meeting at some point in the middle, and they will both will, like all 3 of them will coalesce. Suppose it reaches here and this reaches here, and they collided and coalesce, and now it become one. This is your particle C with 2 kg. So, and now when they coalesce they become E. Now it's no longer particle D. and they become E, and now they are moving towards Z. Yeah, okay, this is like the whole scenario that is here. Now what to do next? Let's look into what are they asking for. This is particle D, C, and this is E. Was A, B, and C. Okay, now what are they asking for? They are asking for, show that after the second collision the speed of E is 15 minus V over 4. Okay, now they are referring to the speed of E. So what are we supposed to do? We will be finding the first collision, the speed after first collision of the particle D, and then the particle speed of E after second collision. So here represents the second collision. Okay, it seems a little off, no longer of the same size. Okay, so now let's get to the working of this further. So we'll apply the conservation of momentum for the first collision. For first collision, it would be, what is going to be the conservation of momentum? Let's write it first. MA, because your particles are A and B, so MA VA, or you can refer to it as UA because initial speed, plus M of B times V of B, or U of B because initial speed should be equals to MA VA plus MB VB. So what is your mass A? 5 kg. So 5, and what is the initial speed of A? 6, plus mass of second is, like particle B is 1, but initial speed is 0 of B. Secondly, now after collision what happens? This A and B coalesce, so it will become 5 plus 1, the mass, times the velocity of D, and that we need to find. So also the conservation of momentum for coalesce would make some form as M of A plus M of B times Vd, because now they have coalesced, so they will be having the same velocity. Okay, so solving this all will give you 30 divided by 6, and that is 5. So now velocity of D would be 5 meter per second. Okay, so now this is 5 meter per second, this velocity. Okay, we found it to be, but they haven't asked us for this one, they asked us for the velocity of E. Now considering the second collision and applying the conservation of momentum for the second collision, so instead of writing that all again, I am just copying this. So it will become for second collision it will be m. Now the two particles that are going to collide are this particle d with c. Okay, so we will be taking m of d u of d plus m of c u of c equals, now these both particles are going to coalesce and become E. So m of d you can write, or individually you can write, because d is also a plus b. So m of a plus m of b plus m of c, because now all these three coalesce and become E, times velocity of E, because they all will be having the same velocity ve now. Now substituting the values, we know that we take like one direction to be positive, a convention for a particular question. So we are taking the rightwards direction of velocity to be positive, so the opposite of it will be negative. So now the velocity of c would be minus v, because it is moving in the opposite direction. Okay, so what is mass of d? 5 plus 1. What is ud? Obviously we found it to be 5, plus mass of c is 2 kg and velocity of c is minus v. Okay, so it will be equals to, what is a? 5 plus 1 plus 2 times VE, and we now need to keep this VE out and solve for VE. It will become 8 and 30, it will become 30 minus 2V over 8, V to be equals to VE. So if we take 2 common from the numerator, it will become VE will become 15 minus V over 4. Okay, so this is your VE that you needed to be proving it to be equals to 15 minus V over 4 meter per second, and this is what we have proved now. Now look for the part B. Okay, question 6 part B is the total loss of kinetic energy of the system due to 2 collisions is 63 joules or joules. Use the result from A to show that V is equals to 3. Okay, so we need to find the velocity. What is V? V is actually the velocity of C particle. So they are asking us to find that. Okay, 63 joules. Now let's look into this. What does loss of kinetic energy means actually? Loss of kinetic energy will be equals to initial minus final. Okay, what will be the initial kinetic energy? Initial kinetic energy, only particle A and particle C were moving, particle B was at rest. So initially only we have these two velocities, so we will be having these two kinetic energies only. So half mv square for both, so half 5 times 6 and half 2 times v square. So it is going to be half ma ua square plus half mc uc square minus final kinetic energy. And what will be the final kinetic energy? Final kinetic energy is the kinetic energy of this particle E. Okay, so half m of E and v of E square. Okay, this will be your loss. And what is your loss? Loss is equals to 63 joules. Okay, so let's solve it out, put in the values and solve it out. So it will give you the initial kinetic energy of particle A is, mass A is 5 and initial speed is 6 plus half mass of C is 2 kg and its velocity is minus v minus half. Now particle E is the coolest particle, so masses would be the sum of all the three masses, so 5 plus 1 plus 2 and velocity is ve. Okay, let's put in the velocity that we found ve in the last part, that is 15 minus v over 4. So 15 minus v over 4 square. Now solve it for v. So this first will become 90. 5 times 6, sorry, this is square, so 36 times 5 divided by 2, this will give you a 90, plus this 2 and 2 will cancel, so you will end up having v square, okay, minus half. Okay, you have this, firstly square will be applied in the denominator, 4 square 16 and 16 2 times would be or just keep it this way and solve it further. So minus half, 5 plus 1 plus 2 is 8 and then open the square, 15 square plus v square minus 2 times 15 is 30 v. Okay, then divided by 4 square and 4, so let's say 4 square like this, because we need to like solve some of them, so I'm not completely solving into 4 times 8 and 1 4 will be cancelled with this 1 4, so we are finally just left with 1 over 4, 225 plus v square minus 30v just solve it together. We can multiply the whole equation by 4 to just get rid of this denominator 4. So we will be having it as 63 times 4 would be multiplying by so it will become 252 equals 90 times 4 would be 360 plus v square minus 225 minus v square plus 30v. Now solving v square and v square will be cancelled out. We is it fair now? No, wait, it won't be because we multiply the whole equation by 4, so it also becomes 4v square. Okay, so 4v square minus v square will be 3v square. So 3v square plus 30v, and then solving this 360 minus 225 minus 252 will give you minus 117. Okay, so dividing it by whole by 3, it will give you v square plus 10v minus 39. Now solving this quadratic equation will give you eventually two values of v. So which two possible values of like two factors could be? When you multiply you will get 39, and when you add them up you get 10. So it will be minus, no, not minus, if we get 13v minus 3v, so you will get minus 39 v square, and when added up it will give you 10v, positive 10v. So let's take that common. V plus 13 minus 3 times v plus 13 equals 0. So v minus 3 times v plus 13 equals 0. So v is going to be either 3 or v should be equals to either minus 13. So now which one to choose out of these? As they said, use the results from A to show that v is equals to 3. So that certainly means we will be considering this one, and this we will be rejecting this one. Okay, so this is your part B. Now let's move on to part C of the question. Okay, this is part C. It is given that the distance xy is 36 and yz is 98 meters. Find the time between the two collisions. Okay, xy 36, x to y, it's it's 36 and y to z just 1 second. second, there is a little, it is 36 and this is 98 meters. Okay, this is the distance between x to y and y to z. Now what are they asking? The time between the two collisions, means between the first and second collision what is the time. Okay, one thing that I want to mention on it is the velocity of c that we just found to be 3 meter per second. So I also want to mention it here. So it would be 3 minus of 3. Okay, so let's write it this way so as to differentiate that we have written it afterwards. Okay, now why do I need this? I just want to take this all downwards so that we can understand it more clearly and do the questions on in the given space. So this is your okay, so we have now mentioned the distance. Actually, what do we need? That when this particle c has covered some distance, okay, one more second, I just need some different color. So when this particle c has covered some distance from z to forward, this a particle has reached a point y. Okay, so what do we need? In these type of questions we actually make some equation with the distances so as to find the time when we need to find the time between the two collisions. Okay, so what we will be doing, you know that the distance between two like the time between the two collisions, we know we will be using s equals to vt. Okay, so what will be the time in between when d covers d reaches c and c reaches d, so they will collide somewhere in between, so we need that time when they collide. So if we look into the distance way, you can see that the distance at which they will be colliding will be equals to the distance covered by c plus the distance covered by d. Okay, I hope it makes sense to you that the distance that is going to be covered by particle c to reach somewhere here will be plus the distance covered by d will be that, like this will add up to this distance s. Okay, and we need time for this. So what we will be doing for this, if we write it up in terms of s equals to vt, what we will be writing it as, we will be writing it as, we need this distance, like how much they are apart from each other, c and d. Distance s of c would be v of c times t. The time for both of them will be same. Okay, because they took the same time to come at the common point. And s of d would be v of d times t. So in this whole, we know v of c, we know v of d, we need to find t, but we don't know what is the distance between them. So let's first find out that. Okay, how to find out that? They say the distance, this much is 36 and this much is 98. So what is the distance in between? So for this one, if you find out how much distance the A has covered to reach point Y, will be equal, will be the same time in which the particle C has covered some distance. So let's find out that. You will be finding out the S equals to Vt, applying it on particle A. What is particle A doing? The distance is you know what is the distance, how much distance it has covered? Yeah, for sure we know that it has covered a distance of 36 meters. Okay, because it hit particle B that was at rest, so it has covered 36 meters to reach Y point or particle B. So velocity, we know initial velocity was 6, and time we need to find how much time it took to reach particle B. So t will be equals to 6 seconds. Okay, now S equals to Vt apply for particle C. The same time particle C has took. So particle C has covered the same like how much distance it has covered we don't know, but it has covered some distance in the same time, 6 seconds. Okay, to reach from point Z to some point in between Z, Y and Z. Okay, so this would be, what is the velocity of particle C? We know it to be 3, we just found it. So 3 times 6 will be the distance particle C has covered. So this is 18 meters. If this whole distance was from Y to Z, like the distance from Y to Z was 98 meters. Okay, so now the distance between D and C would be 98 minus 18, and that would be 80. So now this 80 meter needs to be covered. Actually, we should be taking this. Okay, this is your actual equation in which you will be substituting your of all the workings. So I am not doing it somewhere else, I am doing on the same page. Okay, so now apply this distance. This is the distance that D and C has to cover. In which time? You need to find that time, because you need the time between the two collisions. So 80 will be equals to, velocity of C is 3, time we don't know, plus velocity of D, and the velocity of T we know it to be 5 times T. So it will give you 8T, and T will be equals to 80 over 8. So time will be equals to 10 seconds. So this is the time during which your particle D, like the time between the first and second collision means the particle D and C collide to become E. Okay, so this is your whole working of your part C1. Now we have another part to this, part C2. Find the time between the instant that A is projected from X and the instant that E reaches Z. A is projected from X and E reaches Z. Now that means you need to find the time for the whole journey. Okay, from A when it started and hit at B, and then B and D collided and collided with C, and then obviously this A, B and C collided somewhere in between, and then it moves to the right with some velocity to reach Z again. So we need time for the whole. So how much time do we have? Actually, we know some of the times. again, if it will be more better if I take this diagram with me further. Okay, so time by total time would be time for particle A to reach B plus time for the D particle to reach C. Okay, this time A to B is the same time that C reaches to C somewhere here in the middle, okay, from Z. So, and now then there was a time then D and C approached each other, and when they collided, so there is a time T to C. And thirdly, the time when they all three are 1, and the time took by E to reach point Z. Okay, I may not be writing it correctly, this whole working. Okay, like I'm not writing it correctly means that this is not like a patent thing. I am just making writing it to make you understand this. Okay, so because sometimes I am using the particle's name and sometimes I am using the point name. Okay, so it's fine, it's just for your understanding. Okay, out of all these we know that this is 6 seconds, A to B is 6 seconds. We know that D to C it took 10 seconds. We only need to know how much time E took to reach Z. So for this reason we should be knowing how much distance is left for particle E to cover to come to Z. Okay, so let's find out. We know, first let's find out what distance D has covered, okay, in 10 seconds when it approached C. So it would be equals to VD times T, and that is you can say D approaches C. Okay, so velocity of D is 5 and time it took to be 10 seconds. Okay, so the distance it has covered is 50 meters. Now this is the 50 meters it has covered to reach C. Now how much then they collided? Okay, so somewhere where they collided, the distance they have covered to be 50 meters. Now how much is left? The total was 98, so how much is left now? Distance between point of collision and Z, point of second collision, it would be 98 was total minus 50 meters, so we are left with 48 meters that needs to be covered by the particle E. So 48 meters would be we need to find time, so again apply S equals to VT for this, V for E and distance that E has covered. So 48 meters it has covered with velocity. What is the velocity of E? Have we found it to be? Yeah, we found it to be in the first part I guess 15 minus V over 4. So 15 minus V over 4 is 15 minus 3 over 4. Okay, and that is 12, sorry, over 4. 12 over 4 is 3, and T found it to be 16 seconds. Okay, so this is your third time, 16 seconds. So okay, so this will add up to give you 6 plus 10 plus 16 is 32 seconds. So this is the total time of your journey. Okay, this working is just to complete the above working. So we are just rewriting it a little below. Okay, and yeah, this is your final answer. Okay, I hope you understand. It was a bit lengthy question, and I also tried to explain every bit of it, like explained it whole. It took a lot of time, but no problem. I hope you understand this question. Thank you.